Welcome friends, in this video we are going to look at mathematics paper 2 for the year 2023, and we are dealing with question 12 from section B. Now the first question is evaluate. So we have been given the sigma notation, -1, +1, then the inside part will be written as -3x squared minus 1, then dx. So the value on top is called an upper limit, then the one here is our lower limit. So whenever you are given limits, it means that you are dealing with a definite integral. So the first step that you are supposed to do under a definite integral or integration is we need to add 1 to the power. So the first expression that we have is -3x squared. So this will be -3x squared. You need to add 1, then you divide over the same 2 plus 1. Then what of the case where you are given a constant number? So the constant number, whether 1, 2, 3, any number that you are given, you need to multiply by x. So -1 times x, we get -x. Then we are evaluating from -1 up to +1. Then from there, we can just simplify the inside part. So this is -3 over 3 times x raised to the power 3 minus x, evaluating from -1 to 1. Then we can cancel this. So the final integrated function is -x cubed minus x, then integrating from -1 to +1. Now we are done integrating, and under a definite integral we don't need to add the constant of integration since we have been given the intervals. Now what are we supposed to do after we are done integrating? So we are just going to write you write -x cubed minus x, then for the first part you use the upper limit, which is +1. Always you subtract, then you write exact thing here, -x raised to the power 3 minus x. This one must be evaluated using the lower limit, which is -1. From there we are going to do substitution. So where there is x for the first one, I'm going to put the upper limit, which is 1 raised to the power 3 minus 1. Then for the second one is negative. Then here we have -1 raised to the power 3 minus -1 also here. So whenever you raise a number such as 1 to the power 3, the result is still 1. Because we know that 1 times 1 times 1 is 1 times negative, that is still -1 minus 1. Now for this part, it's -1 times -1 times -1, and do not confuse the inside negative with this negative here. This negative, it is the negative that we just have. So the inside will be -1 times -1 times -1 will still be -1, then times the outside negative, which is +1. Then negative times negative will give us +1 also here. Then we are going to add, here we get -2 since we have the same signs. Then also here we have 2, which is our final answer. It's just -4, which is the same as 4, because the definite integral simply means we are just calculating the area. So that is how we can integrate. Okay, we move on to question B. The diagram shows the graph of y is equal to x cubed minus x squared minus 5x minus 3. This is a cubic function. So now, and this time we have been given a cubic function that has been plotted for us. Now let's have the first question. So the first question is use the graph to find the solutions of the equation. So the first equation is we have x cubed minus x squared minus 5x minus 3 is equal to 0. So what are we supposed to do? So with this, we have this original equation. So we are going to use the original equation. We compare with the equation on the left side. So the first question that we should ask ourselves is, are these two the same? So we can see that they are the same. So where there is this, we replace with y, then we equate to whatever number that comes after in equal sign. In our case is 0. So we are dealing with we want to find the values of x when y is equal to 0. So when y is equal to 0 is just the x-axis. So we need to find the values of x where the curve is meeting the x-axis, and we can see that we only have 2 points here. So the first value of x will be x is equal to here -1. Then the second one will be x is equal to +3. We move on now to question B. So question B, we have x raised to the power 3 minus x squared. 5x is equal to x minus 3. So let's do the comparison. So from the comparison, we can see that this is now different. So in a case where we have a different equation or function, what are we supposed to do? So what we are supposed to do is we need to make this part to be exactly the same as this one. Now the only missing number here is -3. So we are going to add -3 so that we can have equal. So we write x raised to the power 3 minus x squared minus 5x. So we need to add -3 on the left side. We also have to add -3 on the right side. So whatever that you do on the left side must be done on the right side. So we can now see that this is exactly the same as this. So we replace with y. So y is equal to x. Now -3 minus 3 is -6. So we have formed what we call a linear equation. So we need to find the coordinates. So we are going to make a table of values. So we need to begin with 0. After 0 we have 1, +1 or -1, 2, until we find the values. Now we can just look at this directly. We can't use 0 because if we replace x with 0, y will give us -6, of which we have. But whenever we replace y with 0, x will give us -6. I mean +6. Now our graph under the x-axis, we don't have the value of 6. If we try 2 will not work. 3, so 3 will also not work. Now let's try -3. So let's say x is equal to -3 since we have the x value of -3. So we can now say y is equal to -3 minus this one. So y is equal to -9. So this is -9 here. Let's solve for x. So where there is y, we put -3. So this time we put -3. Then we have x minus 6. We can now collect the like terms. So -6 will shift to the left side, giving us +6. Then the value of x is +3. So we have 3 here. Now after we are done, we can now plot the coordinates that we formed. So the first one is -3, -9. -9. So -3, -9. So if -5 under x is here, so we need, if we count those two smaller boxes, 2 smaller boxes makes 1. So we have -6, -7, so -9 is somewhere here. So I put the cross. Then the other one will be 3, -3. So 3, -3 is somewhere here. From there, you need to draw a straight line. Make sure you use a ruler. So we are going to draw a straight line that passes through those 2 points. And the equation, we have the equation. So now, what are we supposed to do after we are done with this? So we need to consider the points where the straight line or the straight equation meets with the curve. Then we are going to draw dotted lines into the x-axis where we are going to get the value, since we are told to solve the values. So let's do that. So the first one is here. So you need to draw a parallel line to the y-axis. So the point at which this line is falling on the x-axis is the first value of x, which is under the x-axis. The smaller box is 0.1, so negative 2.1, 2.2, almost 2.3. So that is my x value, negative 2.3. Let's look at the other one. The other one is here. We do the same. So 0.1, 2, 3, 0.4. So I'm getting 0.4. The other one is here, 2.7. So x is equal to 2.7. So this is what you are supposed to do whenever you have a case like this one. Okay, so we move on to Roman number 2. Find question A, gradient of the curve at a point negative 2, negative 5. So let's find that point, negative 2, negative 5. So negative 2, negative 5, it is at this point. So how can we find this gradient? Let's draw a line that will, let's say a tangent that will pass through this point. Now, after we are drawn, we know that the formula for gradient is y2 minus y1 divided by x2 minus x1. Now, we only have one pair, which is negative 2, negative 5. So we need another pair. So where can we find the other pair? We are going to get any 2 points of our choice within the line that we have drawn. So now make sure the point that you are choosing, please make sure that you choose the point that will not give you issues when finding the final answer. So let's say I will take them from here. So if I take them from there, the y is negative 10, then the x is negative 2.8. So we can now find the gradient. So we'll say x1, x2, y1, y2. So gradient is equal to y2 is 10 minus x2 is negative 5 over x2 is negative 2.8. We have minus, so this should be minus 10. So minus, then x2 is negative 2. So here we have negative 10, negative times negative, positive 5, over, we have negative 2.8, negative times negative is positive 2. So on top we have negative 5 over, here we have negative 1.8, which is, we cancel the negatives. So we just have to do 5 divided by 1.8. So I'm getting about 2.78. And this is just an approximation. Now, let's say we want to use the calculus to find the actual gradient, because for the calculus, we can find the gradient at this point, since we have been given the coordinates. So let's go back to our original equation. So how do we use calculus to find that? So the introduction of calculus under mathematics can help us to give the actual value. So this is an approximation, but we want to find the actual value of the gradient at this point. Remember, the point is negative 2, negative 5. So that's what we are going to do. Then we'll compare so that we are able to see the difference. So the equation, the original equation is y is equal to x cubed minus x squared minus 5x minus 3 at a point -2, -5. So what we are supposed to do is you need to find the first derivative of this equation. So we are going to differentiate with respect to x, which is dy over dx. So you multiply these 3 times the coefficient of x, which is 3, x raised to the power, you subtract a 1, 3 minus 1 is 2. Then here we do the same, 2 times -1 is -2x, then 2 minus 1 is 1. Now for this case, we only have a 1, so 1 times -5 is -5, x, 1 minus 1 is 0. Then the derivative of a constant number is always 0. Where there is dy, we can replace with m. We have 3x squared minus 2x minus 5 times 1. Where is the 1 coming from? X raised to the power 0 is equal to 1. So m is equal to 3x squared minus 2x minus 5. Now for us to proceed by finding the gradient, while there is x, we put the x value from the point that we are given. So we put -2 squared minus 2, -2 here minus 5. So gradient is equal to, here we have -2 squared is 4, 4 times 3 will give us 12. Here we have plus 4 minus 5. Then our gradient will be 16 minus 5, which is 11. So according to calculus, I'm getting the value of 11. So that is the answer. So that is the actual answer, and you can see the difference, 2 to 11. So the one that we used earlier is just an approximation. We were just approximating. So that is the point. Okay, so now we look at the last question. For the last question, area bounded by the curve x is equal to 1, y is equal to 0, and x is equal to 3. So first let's look at where we want. So the first one is x is equal to 1. So in here we are going to draw the line that will pass through that point. Then we have the curve. From there, where else are we supposed to look at here? Y is equal to 0. So y is equal to 0 is the x-axis. So it's like we are making the boundary. So let me draw the line for that. Then you will have the curve. Then what is our third point? The third point is x is equal to 3. So x is equal to 3 is here. So the area that we are looking for is this area here. Okay, so now how can we find the area? So let's look at the one box. Can we find the area of one square box here? So this is the one square box. Now since under the x-axis 2 centimeters was representing 1 unit, it means from here up to here there is a 1. Then under the y-axis from here up to here there is a 5. So this is the longer one is the length, then the shorter one is the breadth. So even if it's square, we are going to consider it as a rectangle. So the area for a rectangle is L times B, which is area is equal to, what's our L? 5 centimeters times 1, which is area is equal to 5 units squared. So this is the area of this complete one. Now for this one it is incomplete, but look at this point here. So we are going to get this point, then we can just put it here, so that we can consider even this one as a complete. So we have 2 completes. Then for this one it is almost 3/4 of that. So it is 3/4 of that. So we just say area is equal to 5 times to the complete one plus Then this one we just say 3/4. It's 1/3. It's 1/3. 1/3 times 5, which is, here we get 10 plus 5 divided by 3, so which is 1.2. So area is equal to 11.2 units squared. And remember, these are just approximations, so you may find a different answer from this one. It's not, doesn't mean your answers, your answer will be wrong. No, these are estimations. So that's it for this video. Thanks for watching.